All right, let's try this one more try. One more time. For today is day 4. We're going on with Chad in ITF Module Kick Off. The majority of us did that, I believe, last week, if not throughout the week. He'll explain the details of how to do the audit course if you haven't gotten into the audit course. And followed right after that will be Gage with adaptability. And lastly, we'll do our daily reflection where we reflect on the question that is given to us and fill out the barometer. Questions, concerns? None? All right then. I guess I'll pass it off to you, Chad, for the local sports and news.
Yeah, sure. All right, so this is about the point in time we would ask y'all to do ITF. I know we kind of got y'all started on it very early, but that was a good reason for that. Also because of the learning curve for y'all to be able to upload assignments. So at this point, we want to make sure that it's clear and there is no question on how you do, how you know what is due, how to upload assignments. I'm just gonna put out there that if you need to re-upload assignment, you have to actually reload it, not just leave a comment with uploaded site. So give me 1 sec and lovely. All right, so we all know. Let's talk make sure that we're supposed to be doing that. Your assignments they're doing on calendar. ITF one is due Sunday at midnight. Remember that. If you have any other assignments, which is the only other assignment that y'all had to do was the scavenger hunt. If y'all still haven't did that, please turn that in. Uh, is there any questions on how to submit, on what assignment that's supposed to be? For example, for ITF one is supposed to be the graded assessment on Coursera. Is there any questions on?
And that's
saying,
how to count binary, correct?
yeah, how to count binary? It should be the last assessment. Also, I'll bring that up as well.
Could you
I have
give
an
me
issue
a
with that.
quick refresher on like how we would go about uploading assignments? I wasn't here for like the first 2 sessions where we covered that.
Sure. You go to the calendar. This is one of the assignments that y'all need to turn in. It will show up on the calendar besides the regular days that you see on the calendar right here. It can either it will come up here or it can come up under a day. Mostly, it'll be on the weekend. Usually, it'll be on a Sunday, like at midnight. I know some of y'all are showing up on Monday. But regardless, it'll be due before that week start or on that Monday, right? You'll go to the assignment that is due. You'll click the link. You'll open it. You'll say start assignment. You'll upload the screenshot of whatever we need for that assignment, and then you'll just hit a submit assignment for this assignment in particular. 1 sec to log in really quick. That was for how to count the binary for week 1. If y'all have questions about the assignment or what it's due, remember you can always
For the
Slack.
screenshot, we use the snipping tools, right?
I'm sorry.
For the screenshot, we use the snipping tool, right? Snipping tool, that is the one on the Windows.
Yeah, you can use the snipping tool.
Yeah, okay.
Are the
Yeah,
instructions?
ITF 1. ITF 1, week 1, all the way down. How to count the binary. It should be under graded assessments. All the other practice quizzes we don't need. That's all for ITF 1. That's all we need. How to count the binary. How to count the binary. Right. You'll go to the assignment. Do the binary. You need to make sure to check for answers. It'll glow red if the answer is wrong. It'll glow green if the answer is correct. Once you have all of that, you've done all of that for the binary calculator. You'll screenshot the binary calculator and submit it in the Canvas. That's just for ITF 1. ITF 2 isn't due until the next week after this
Alright.
assignment is due.
Dominique, you had a question? I'm sorry.
He's kind of answering it, but my question was just really, are the instructions listed on there on how to do this?
I believe there's videos in reference to how to do this, but I mean, if you guys don't understand the videos, we'll gladly explain
Explain
it
it.
here and try to. Are you guys having any difficulties with the binary and understanding how it works?
That was the whole. Well, this is just introduction to IT support, but it goes into
There's a video or
binary.
two, yeah. There's like a 2-minute video and
Yeah.
then a 3-minute video.
The video is
Mhm.
like 3 minutes on how to count the binary, how to count in binary.
I had an issue with that. Are we supposed to actually submit the Coursera answer when you do it? Because it's asking me to purchase the course, to pay for the course when I like actually try to submit the answer, but that's via Coursera. So do I just like actually get the answers and then and screenshot and not hit submit with Coursera?
Correct.
You're not. Yeah.
Okay, cool beans.
You don't have to buy that. Just, you're exactly correct. If it's telling
So
you to
the-
buy something, then just stop and take a screenshot and don't submit it.
Cool
Don't let
beans.
it, don't let it grade it. We'll look at it over here. The ultimate goal, so everybody understands, here is for you guys to attempt and to understand the information, look at what is there. And then if there's any issues at all, feel free, bring those questions here so that we can all be able to benefit from the questions and debate and hopefully clarify anything that's not clear. We're not saying that this is gonna be 100% clear for everybody. And sometimes, you know, since some people are a little bit or have taken some other courses before this, we try to be as flexible as possible. If not, we'll be here just spitting out presentations and boring the living daylights out of everybody. So. sorry.
If we've taken this
Sidetracked.
before,
Yeah. Mhm.
can we just upload the screenshots of what we've already done?
Of course,
Yeah.
yes.
If you've taken it before, just
Mhm.
just screenshot your certificate for the ITF assignment.
Mhm.
That's all we need.
Awesome. Okay, thank you.
You're welcome. All right.
Destiny?
Anything else?
Yeah, I have two questions. So the first question is, in Slack, we were told to upload 2 assignments, which was the binary calculator as well as the binary quiz. So which one, do we upload both or do we just upload the graded assessment?
It's just a graded assessment. It's
Okay,
just
so
how to count the binary.
in the future, when we go through these modules, it's always only going to be the graded assessment.
Right now, yes, because since we're only doing Coursera for the beginning introduction to IT,
Okay.
we won't be dealing with Coursera in the next few weeks. Because after we're done with Coursera, after y'all get
Yeah.
through like week 3 and week 4, we are going to be transferring to A Cloud Guru, and that's when you'll be doing. It'll be in similar format, but you would actually do everything. Y'all have videos, y'all have labs, y'all need to complete. Y'all have more assignments, y'all have a completion cert that eventually I would need to turn in, and then we will start getting more technical and we'll have, extra presentations as needed.
Okay. And my second question is, I think some of like the confusion about the assignments, I don't know if I didn't see it, but when we go to upload the actual assignment, there's no like title for what assignment should be uploaded. because I know a lot of people asked in Slack, like, hey, what specifically are we supposed to be uploading? So like, you know how the title says how to count in binary, like maybe when we went to go like upload, it might say it in there, or maybe did I just miss that, or?
I believe so. Yeah, in Canvas, you're saying? Yeah, if you
Yeah,
go
in
to the link,
Canvas.
if you go to the link inside Canvas, there's a link that should take you to this specific spot in Coursera. So if we can go real quick back to Canvas and we look at what was that, Sunday? I think it's when it's due, right?
Yeah, this section right here
It
where you're
said-
uploading, does it say binary or something like?
Right now, that just
You see where it
ITF
says,
one.
it doesn't have a link before that? You have a link somewhere.
Hold on.
Leave
Let
a
me
page.
cancel this real quick. All right, previous.
Oh, there it goes. There it goes. No, sorry. Go back.
Yeah, no, this is
Right there, that guy right there, the white guy. The little picture, believe it or not. The picture in the middle with the white thing
yeah,
that looks like
you're
Google.
talking. Yeah, you're talking about the
That
link.
guy right there. Click on that guy. Yeah, they don't put a title on it, right? So yeah.
All right, thank
And then
you.
the next one is, but you'll see it, if you read carefully, it says it there. You have 30 minutes once you begun. And so it kind of says it there. And but you know, it's the picture. You click on the picture and it takes you.
Yeah,
that
if
help?
we go to calendar and if we go through, well, let me go ahead and show that real quick. On day 5 on your asynchronous sessions, how it goes through session 1, session 2, session 3, session 4. These pages that the do edit is on is embedded in those pages, so eventually you'll come across it. So it works like that, but also you can see when that assignment is due.
Yeah,
Right, separate from that.
I just did it a different way. Like when I went into Coursera, I noticed that each of those assignments linked with each session. So I just ran through it on Coursera and I didn't realize that when I went to upload it, there was also a link for the upload attached to the actual assignment that we had to upload. So that's where my confusion was. That was on my part.
All right, no,
That's
gotcha.
fine.
It'll be just for further notice is all. It'll be very similar like that to A Cloud Guru, but it'll be more straightforward. I feel like it'll be a lot less confusing once y'all get an A Cloud Guru. Anyone else? Any questions?
Adese?
Yeah. Hey, chat. Can you hear me?
Yes, or whoever is speaking, I can hear you.
Yes. Now my screen was blank and I had to reboot my laptop. Do you mind to go over just briefly what you showed us the first maybe 5-10 minutes? I had to reboot my computer, please. Thank you.
Okay. Go ahead and root your computer. There'll be videos on Canvas. If not, does anyone else have a question about any of this? We're kind of rehashing
I
the
do
same.
have a question.
Yep.
Yeah, so I noticed for the resume and LinkedIn assignments that we need to do, I just want to confirm if there was a special way that we needed to log into JobScan, or can we just sign up for the free?
Sign up for the free account,
Yeah.
because all that's gonna all the JobScan is gonna do is just scan your account and give you recommendations on it. That was the whole thing about JobScan. There's no like credentials generation gives you. There's no anything. You're just gonna sign up for a free account, eventually scan the resume that you have, and try to improve your resume based on some of its suggestions. So it'll
Got
be
it.
based on continual improvement.
Join the meeting.
Thanks for verifying. Thanks.
Yeah, you're welcome. Anyone else? Also, want to remind y'all, there's a lot of videos of us explaining this stuff in Slack as well. Use our resources. They're there. I guarantee you it'll help a lot.
Can I ask a
Um,
question about the binary assignment?
Oh, yeah, what about?
So I was a little confused when I was going over it. This might sound a little slow, but so I took a picture of the little thing and it was saying like 2 equals 1, 2 to the 0 power equals 1, and
Mhm,
2 to the first power equals 2, and all that stuff.
mhm.
And
Right.
then at the end, it shows me 0, 1, 0, which according to my notes means that something is an uppercase letter. And then there was 0, 0, 0, 1, 1, and it all equals 67. And then
Okay.
it tells me that it's concentrating on the 2 and the 1. But is 67 supposed to mean FG?
There's no G. So if you could give me, I mean, are you talking binary to hexadecimal now there at that point? Because
ASCII.
ASCII,
Oh, is that what that means?
that's it's pronounced ASCII, but
Oh, ASCII.
ASCII, yeah, that's basically what's used to be able to call out. See, everything in the computer is either on or off. The only way it can actually know what a character is based on a value. So the number 67, which is somewhere, I think, what is that, like C or D in the alphabet, or letter G maybe in the alphabet? I can't remember. I think it starts around 60
Well,
something,
6
the
is
lowercase.
F
Okay,
and
so
G is 7.
okay, so based on the ASCII value, it's able to send across in. You remember in the movies or anywhere else where we used to have Morse code. So this is how it's talking to it. The only way it can send this signal is be able to do the short, long. And it has a method of being able to do that. When it's able to do that, it can send letters across the network or the light or wireless. That's why it uses ASCII. Without ASCII, there's no way it's able to decipher the beeps or what they call bits in network. Each bit, which is a 0 or a 1, will give you a actual value for each one. Now, what are they talking about in this binary stuff? It actually stacks. It starts from the right, physically you can see from the right going towards the left. So you have what they call 2 to the 0. Remember in math, if we go to the power of 0 and anything, it always equals 1. Now, forget about that. What you need to do is unfortunately start playing this game, and I had to play this game, and memorizing the order of the numbers. We all know that now it is a base 2, just like we know when in a base 10 that if I say a 1, then the next one will be 10, then the next guy is 100, 1,000, right? And so forth. Just like we could do that game because we played that game when we were a child and learned it. Unfortunately, we're going to have to learn this when it comes to binary. What do I mean by that? 0, 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 20, 48, 40, 96, and 81, 92. If you can play that game in your head, then you have successfully became your own little calculator. This is binary. It skips that way. And unfortunately, you've got to be able to at least get from what they call an entire byte, which is the first 8, which is from 2 to the 0 to 2 to the 7, which can give you from any value of being 0 to 255, which is a total of 256 valuable characters. But Diego, you just said 255. Yes, but 0 is a number. Therefore, it is a value. In computer, 0 still gets counted. It's an actual number. It's not an imaginary number. So did that help a little bit?
Yeah, it did help a little bit. In the chat, somebody asked, are we expected to memorize ASCII? And the answer was no.
No,
But
there's no way. What you do need to learn is basically the values of being able to play this game in your own head. Mind me, I am a very good Picasso. I will be charging for these pictures. All right, so 2 to the 0, 1, 2, 4, 8, and then 16. You got 32, 64, and 128. So when it wants to send the, sorry, how did I miss that? No, I did that. When it wants to send the data, it has to turn the bit. So each one is a bit, a collection of 8 bits. It's a byte. Question so far. A bit is a 0 or a 1. A set
So-
of 8 aligned. In other words, you know when I'm going, I do that in 8, in groups of 8. That's a byte, one entire byte. That's 8 bits. Questions?
So as far as bits, we should kind of think of them as like numbers, basically.
Bit
So a
is
bit
either a
basically is
0
equivalent-
or a 1. It's either on or off. That's all it is.
Well, just to
And then-
kind of like make it like easier to understand, like a bit, like, okay, so if we're saying if 8 bits equal 1 byte,
Mhm.
then each bit essentially is like, it's a digit. Like, just think of it like as a digit. Like there's 8 digits equal a byte, basically.
Either
To kind
a
of
0
simplify
or a
it.
1. It's either a 0
It's
or
a 0,
1.
yeah, it's 0 or a 1, but like that's kind
Mhm.
of like a way to simplify it, basically.
Mm-hmm.
Okay.
If you were playing a lotto and the choices was 0 or 1, I would agree with you.
Okay,
If
okay,
that's what
yeah.
we're trying to say, the
Yeah,
only magic
yeah.
involved is that. And that's
Yeah.
what we need to then understand is, so now we understand that it's sending Morse code and it starts from right to left. Depending when it sends the 0 or a 1, a value is turned on. So if someone said 67, right, earlier, we know then 67, if when I want to calculate it for myself, obviously the computer's too smart, he starts from the right to the left, but I want to calculate 67 for myself. The easiest way usually is I look at this number, is 128 bigger or smaller than 67? In other words, if I turn that on, would that be bigger than 67?
Yes.
Yeah.
Then I'm not going to turn it on, right?
Oh,
Now, is 64 bigger than 67?
no.
No.
So then I can turn it on, right? How much do I have left? Now I have 3 left.
3.
So if I have 3 left, should I turn on 32?
Yeah.
I only have 3 left.
No.
I
No,
want
it's
one
1 and
and
2.
No,
Oh,
One and two.
that's 2 and
I
1.
don't, I can't
we
turn
got-
these guys on, right? There you go.
One,
So somebody said 1 and
One.
2 because I want 3.
Diego, why didn't you do the Coursera videos? It
Because
made it so
they
much
didn't-
simpler. Like,
They didn't pay me. I've been doing networking for over almost 30 years. So yeah, I've been playing with this a while. I don't know how they
Wait, waiting on that
why they
Coursera
teach
check. I
it.
feel you.
Why they don't teach it this way, but this is at least for me, the easiest way to understand it. If we try to go and give me some other complex way, it just gets crazy. I can't. I'm too much like a computer and think like a computer. And when you try to go and create something complicated, it just loses me.
yeah,
So-
this made it way easier because I was understanding the math, but I wasn't understanding how they got the zeros and the ones, like how that calculation came about.
Mhm. So what we need to understand, so like I said, it's going to be anywhere from the range of 0 up to 255, which is that what we were saying also, they also use that to be able to send information when they're coding it in ASCII, right? Which is the alphabet that's allowed, which is an English alphabet with only 256 characters. Now, what we need to understand is that no matter which way we turn this on or off, it can be anywhere from 0 to 255. If I turn them all off, it's 0. You'll notice that every time you get right before you get to the next one, if you always turn them on, it's really 1 less than the previous. So if I turn on the first 2, it's 3. If I turn on the first 3, it's 7. Why? You'll see also the pattern here. 1, if I turn it off and I only turn on this guy, it's 2, which is 0, 1, 0 at the end, right? Now I want 3, I turn these 2 guys on. Oh, I want 4, I turn these 2 guys off, turn that guy on. I want 5, leave this guy on, turn this guy on, and turn this guy off. Just keep on off and on, if you'll notice. And it just continues until he needs to fill up the whole thing. But it does it milliseconds. You just got to understand it needs to be able to send a whole byte and be able to encode it. Now, depending how you, this is just the ASCII part, let alone how you in Windows, how you end the name of a file is how it's also interpreting and being able to code an Excel sheet and all that other mumbo jumbo that you look at, which are fancier. Because this is clear text. Any questions?
Thank you.
Yes, please. By the way, I like the way how simple it is when you demonstrate this one. I mean, it's easier to understand. So to change any decimal number to binary, it's clear by now. But is there any like simpler way to understand for the if it is an alphabet like the one that she asked before, which is ASCII code, for example, G or A something?
That's what I'm trying to tell you is that and no one's going to ask you ever to know that the value of 68, what letter is that? You need to understand that the computer uses that to do that. It's the only thing you need to understand is that. Now, I am a liar. You can create scripts and look it up to create your own little fancy alphabet and mess around with stuff when you're doing fancy coding. Now, I ain't gonna get into that detail, but again, all they need you to understand is everything is either zeros and ones. It started off with the easiest one, which is the ASCII, the original one. There's more complex encodings that have come out after that, which is how they send the series of zeros and ones on and off across the network.
Okay, thank you.
Okay, so, and the only other thing they will ask for, to apologize, is, but that would be, I don't think they do it here. Correct me if I'm wrong. Oh, it's the same whiteboard. How do I start a new one? These little fancy things. I'm too old school to figure out how to now create a new one.
Diego, I wanted to know, are
trying to
2
clear the
and
board?
1 always gonna be a 1 and a 1?
I'm sorry, go ahead, repeat the question.
When you wrote it 0, 1, 0, 0, 0, 0, and then
Mhm.
1, 1, at the end, the 2 and the 1 were ones. And then in the Coursera course, both of the ones that I looked at, they put a 1 and a 1 under a 2 and a 1 also. So is that like something that just is because it is, or why is it always a 1 and a 1 under the 2 and the 1?
Well, no, it's not always. Give me a number that you like to know anywhere, so we can play this game a little further. Give me a second while I write this here. So that was 1. We said this spot, right? So this is bit, the first bit, the second bit, right? 1, 2, 4, 8, 16, 32, sorry, 32, 64, and 128. Can somebody give me a number, or you give me a number anywhere from 0 to 255?
110?
Huh? From 0 to 255, anywhere between 0 to 255.
She gave you 10.
I said 110.
Oh,
Oh, I'm sorry. Okay, 110. Okay. So now, should I turn on the 128 if the number is 110?
No.
No.
Okay. 64, should I turn it on?
Yes.
Yes.
Okay.
Yeah, we can do the next one too. 32. 1.
46.
Yeah,
46, so
one,
46
32,
plus
yeah.
32
0.
is 14. So we
0,
got 14 left. So we have 14 left.
then 0, then 1.
We had 14 left though.
No,
One.
110 is now is
Zero.
we already 108.
Now
We
six
need
left. 6 left, I think.
we need 2.
4 and the 2,
Okay.
Yeah.
and then 0
Alright.
for the 1.
And then there's a 0 here. So with the one you just gave me, I didn't have to turn on these two. You see?
I think that y'all just lost me just now. So while everybody was telling you the zeros and the ones, I think somebody said we have like 14 left. How do you
Okay.
know how many we have left?
I have
Okay.
question.
Okay, give me a second. Wait. We're going too fast, please. Hold on a second. Before we go on to the next question, please hold on to that question. So we started off with 110. Right? I
Yeah.
subtracted 64. I'm left with 46. Do you agree?
Oh my God. Okay. Wow. Yeah.
I
Yeah.
subtract 32, and now I'm left with 14.
Yeah.
Okay. I subtracted 8. I'm left with 6. I subtracted 4, and now I'm left with 2.
Wow. I get it now. So whatever the number is that you're trying to find, we're subtracting all
That
the way
amount
down.
to go, yeah, to get to the end, to be able
So
to
some
figure
of
it
them
out.
have to be 0 or else will it be in a negative?
Exactly, and you'll get the number that you don't want. See, if I turn
Okay.
this one, so it's like this: 1, then we got 2.
Mhm.
These 2 are 3. This one by himself is 4. This guy with this guy is 5. This guy with this guy is 6. The 3 of them is 7. This guy by himself is 8. This guy with this guy is 9. This guy with this guy is 10. See the pattern yet?
Yeah,
then
I
that-
get it now.
All right. So depending how you use the zeros and ones, it will create. So if someone can please give me another number. The person that was about to ask a question, can you give me your question actually before we proceed with another number? The gentleman that had a question, I do
No,
apologize.
I got it. Let's go ahead for next one.
Okay, can I have a volunteer with a number, please?
97.
56.
I heard 97 and 56. I feel like if I'm playing bingo. G97. I-50. No, I'm sorry. It'd be great if I actually had the letter right. People are like, oh my God, he knows the letter. All right, so let's go with 97. Should I turn on this guy here? If I'm looking for 97. Should I turn him on?
No.
No.
All right.
No.
So now, should I turn him on?
Yes.
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 64, 32, 1.
Okay.
You're right.
So then with 32, right?
0,
0, 0,
0, 0,
0, and
1.
1, right? Because 32 plus 1 is 33.
Yep.
All right. Next one was 56. Turn this guy off. So 56. Should I turn this guy on?
No.
No. 0.
No.
Should I turn this guy on?
0.
0.
Okay. So then we know minus 32.
1.
Yeah,
And
1.
24 is minus this guy, right?
1.
It's gonna be 1.
8.
Minus 0.
And then 0, 0,
0,
0. Because I
0.
ran out of numbers, right?
Yeah.
Any questions, doubts, concerns on the binary? We understand the logic.
Yeah.
The only time this will be also mandated is in the more advanced courses like networking or security. When you're trying to do subnetting, that's when you're going to have to again hit this. If you're trying to translate to hexadecimal is the only other thing they may ask of you. But again, it's more of understanding that the hexadecimal is instead of being binary, it is basically starts at 0 and it ends at F. starts at 0 and it ends in F. So it is up to the number 16. So if we go 0, 1, 2, 3, yada, 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 when I get to 9, 9 is 9. A, can somebody tell me if 9 is 9, what's A? If we're talking about in decimal, this is hexadecimal. If this is 9, that was 0 through 9, what would be the next number in decimal?
Is it 10?
Okay, thank you. So B would be what?
11.
11?
D would be what?
12?
D would be what?
13?
Okay. E.
14?
Okay. And F.
15.
All right. Now that we learned earlier to play this little game, can somebody tell me how do I write 0 then? Should I turn any of these guys on if I want to write 0? Should I turn any of them on?
No.
No, right? So then to change from a character of hexadecimal to a character of binary, they're always in groups of 4. They're a nibble. They're not a byte and they're not a bit. They're a nibble. And they're usually, to create a whole byte, you'll need 2 of them. So if I put 0, 0 in hexadecimal is equivalent to writing in binary 4 zeros straight across with 4 zeros, which that means that in decimal that equals 0. Question. What have I said so far? So the first column here, hexadecimal, has 2 zeros. In binary, is since each one is a nibble, I put 4 zeros and 4 zeros, it equals 0. Now, I'm going to do the same thing, but this time I'm going to put a 0 and a 1. What should I put as the value of the first nibble? The first group of 4, what should I put here? Somebody tell me. This is 0. Okay. Now, somebody can help me. How do I write 1 in binary?
3 zeros
Using a
and
nibble.
0, 0, 0, 1.
All right. So that's the same as 1 in decimal. Now, let's go ahead and start playing with the character A. So if we could do, A, I'm telling you, I'm a great, and F. So again, let's start with the left character. A, we said is 10. Can somebody tell me what's the first nibble using the value 10 to represent A? In
1, 0, 1, 0.
0, 0, 1, 0.
1, 0, 1, 0.
1, 1, 0.
Okay, so let's see. This is 1.
Yeah, 1, 1, 0.
2. This is 4. Right?
Oh, okay.
This is 8. 1, 2, 4, 8. It's a nibble. So each nibble could only have 1, 2, 4, 8. 1, 2, 4, 8. So how do I write 10 using a nibble?
10, 10, 1, 0.
1, yeah, 10,
Yes,
10.
that is correct.
1,
1,
0,
0,
1, 0.
1, 0, correct. Now the letter F is 15. So how do I get 15? Using the 8, 4, 2, and a 1.
1, 1, 1,
1,
1, 1.
0.
All right. So,
Yeah.
and that's equal 15. So my friends, you just graduated. You just learned how to write in binary from decimal. You successfully went from hexadecimal to binary back to decimal. Congratulations.
Thank you so much.
We have recorded this and we will be posting it in the YouTube channel, and you'll see also a link inside the Slack channel.
I have a question. How did you get 111 for the
with 15. If you could just show me that again, please.
Yeah, so let's look for 15, and here's my nibble. Should I turn this guy on? If I'm looking for 15, should I turn this place value, which on a nibble, that place value will be 8. Should I turn it on?
Yes.
Yes. Yes.
Now, if I subtract 8 from here, I'm left with 7. Should I turn on the 4?
Yes.
All right, I subtract 4 from the 7, I'm left with 3. Should I turn on the 2?
Yes.
Yes.
All right, now I'm left with 1, so I got to turn on the 1.
Mhm.
So the value of A, as we just learned, is 1, 0, 1, 0. The value of B is 1, 0, 1, 1. The value of C is 1, 1, 0, 0. The value of D is 1, 1, 0, 1. And the value of E is
1, 1.
1, 1, 0, and then 1, 1, 1, 1. That's 10, that's 11, that's 12, 13, 14, and 15.
I have a question.
Mhm.
So, for example, for the value of 1, are you writing out both of those? The first 4 sets of 0, and then the second set with the 1, or would you just say the value of 1 would be 0, 0, 0, 1?
The
Because you
value
see how you wrote
in,
number 10.
in which language, so I could understand. I'm sorry, which one? In binary, hexadecimal, where are we at? Because if I'm going from decimal to binary, the custom is to send a byte of traffic. If you're translating from hexadecimal to binary, then you must break each character into nibbles and always send everything in a byte. Did that make sense? Yeah. So you're gonna always see 2 characters. The 2 characters equal a whole byte because it's 2 nibbles.
Okay.
Each one equals has 4.
Okay. So I guess where I'm confused is where the letters are right there. I see 4 digits, and then at the top half of the whiteboard, I see 8 digits for those.
Thank you. You just hit the mark. So now let's go and somebody tell me on how to write this number. So let's see. Thank you. You just you hit it exactly where I wanted to get to. So let's see here. Can somebody tell me how to? How do I write now? Right. Give me a pencil. Thank you, pencil. Am I back? No. Hello. No, I can't write. Doesn't like me. Thinks that I wrote too much. Let's see. We'll stop the share. Try one more time. All right. We got another. So we want to now try this number out. I'll go with 210. Can somebody help me translate from decimal to binary 210? So if you like, I can start again and do
1,
this.
1, 1, 0, 0, 0.
And then- All right, so somebody said it was 1.
Again, 1.
And then you turn
0.
on 16.
0. one, 0, no, 1,
1 on the 8?
no, on 16, we can put 1 and 0, 0, then the last one we can add 1. Yeah, 0, 0, 1, the last one.
Well, I'm missing 2 more characters.
Is 1 1 0 1 0 0 1 0.
Okay.
I think
Thank-
it's 1 0 1 1 1 1 0 1 0.
Okay, no problem. Let's try it out. It's
We're reading it.
210 minus 128.
It's 1 1 1 0 0 0 1 0.
No, it's 1 0 1 0 1. I think.
0
Give me a
1
second.
0 0 1 0 1 1 0.
210. Actually, hold on a second. 210. Let's pretend we're right. I'm not even gonna play with this little calculator. So
1 2 3.
let's go with this number and say that whatever this is, be that it's 210 or not. Now, as we notice, to create 210 or whatever number we have right now, which somebody says is 1 1 0 1 0 0 1 0, whichever you like to break up. Now, if you'll notice, to get to 256, if I want to write 256 in hexadecimal, I can write FF and it equals, sorry, 255, which is the 256 character. In this case, we just said 1101. If we remember, that would be 84, which is 12, plus 1 is 13. Does anybody remember what letter is 13? We said A was, I'm sorry?
It's D.
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 D. D 30.
Okay. And now, if somebody can tell me what in hexadecimal, how do I write 0010, which would looks to be the second one I'm turning on. So what can I put here? A hexadecimal character. As a hexadecimal character is anything that's 0 through 9, A through F. What should I put here?
A.
What?
0010 is what I'm trying to translate. 2. All right. So if you notice, I just broke apart a transmission that stated if it's 210 or not. I'm not going to discuss that or not. But I just broke that up into 2 nibbles. And to translate that into hexadecimal, it's equivalent to being D2. Did that make sense? Let's try now 128, which is really 1 0 0 0 0 0 0 0. Right?
Yeah.
So if I have a nibble, which is only these equivalent to breaking it up into these things when I'm translating into hexadecimal, and I only turn on this guy, what would be the hexadecimal character that I can change this nibble into? I'm only turning this guy on. I turn this guy on. I'm sorry?
Which guy?
8.
8 and 0. And this is a lot of times when people get confused when they see the hexadecimal character 80 and they think that that's 80. Do we agree that it's not 80? Because I just did it, right? It's 128. Because if I turn only this guy on and I send the whole byte of data across, that character or that spot is 128. Is it starting to make sense? Yes or no?
No.
Yes.
It
No?
is, but I'm missing the 8 part. I think some of the screen is like
Yes, my screen
in
is
the way
blank.
or something because of the chat box.
Oh, you can close your chat box. I believe it has a little button.
I pressed the X, but then it says leave
No,
meeting.
click on the chat at the bottom.
Yeah, and it should be like a little box on the chat. that you
Oh,
can
okay.
close.
Got
But
it.
it's still blank now.
No, yeah, I just
So
started
we-
erasing.
Oh, now you're
Are we
erasing.
missing the
Yeah.
decimals for 0 through 9, like 0, 0, 0, 0, 0, 0, 0, 1, and then 2 would be 0, 0, 1, 0, and then it's 3, 0, 1, 0, 0?
3 is,
Yeah,
if you're
for the
only doing a
hexadecimal.
nibble, if you're only doing a nibble, it'll be 0,
0,
0, 1, 1.
1.
0, 0, 1. So 4 will be 0, 1, 1, 1?
4 would be 0,
1, 0, 0.
1, 0, 0.
Okay, so I need 5, 6, 7, 8, 9.
Let me see if I can get back this guy.
Yeah, my
Alright.
screen is still blank. I don't know.
Yeah, I haven't started writing yet.
Oh, okay.
We got 1, 2, 4, 8. Please do not erase. Somebody's erasing. Not gonna be helpful. 16, 32. All right, now I gotta erase. I wrote too late. Ah. Sorry, give me a second. Let me get my Picasso going. You know what? Hold on a second. Give me a second.
Yeah, it was.
Now you are talking.
I'm on mute. Congratulations for being on mute. Can we do a little mic test while we're on mute? Mic test, mic test. All right. Might be the reason why you guys are not answering. All right, so forget about anything on the right for right now. Let's just concentrate on this box here. We use this for a different class to be able to go ahead and get the IP addresses of stuff. Give me a second. Let me if I can zoom in only into that little box. It stops what it's doing. Wow. One more time. Okay. You guys see the values here?
Yeah.
All right. Let me see if I can Get this. So if we'll notice, if I turn on, these guys messed with this. No, wrong place, wrong place, wrong place. If I turn this on or off, it will change the values of that green box above me. You see this here? This is the value we're trying to get to between 1, 0, and 255. Do we agree? So if I turn them all on, it's going to equal 255. So let's keep our eyes here. Forget about the network stuff. But this is a total byte. And there's 8 bits. So there goes the values there of your 8 bits, right? And that's 2 to the 0 up to 2 to the 7. If I turn this guy on, it equals 128. Everybody agree so far?
Yeah.
Okay. Now, we were trying to do earlier again to make the breaking point of the, let's say AF or 2. Let's do a number here that we want. Give me any number you like from now from 255, from 0 to 255, and we'll create it. One more time.
111.
111. We know we can't turn that guy on. We turn that guy on, right? So, 96, right? Nope, that goes too much. So then we know that we should just turn on these most likely. That's 111, right? So we agree that this is a nibble and this is a nibble, correct?
Yeah.
All right. So let's look at this nibble. Remember, when we're looking at nibbles, unfortunately, now we're only stuck from here to here, which means that each value is either from 1 up to 8. And I can only get from 0 up to 15, which is 0 through 9, A through F, which is 10 through 15. Everybody agreed so far?
Yes. A through F is 10 through 15, right?
Uh-huh.
Yeah. Okay.
All right. So now that we got this number and we're looking at this, let's create that number. If you guys don't mind, I'm going to create it over here. So I'm going to put 0, just a nib. I'm going to make the left nibble. I'm going to create it over here. So it's 0, 0, 0, 0, 0, 1, 1, 0. We agree? If I do this little small nibble, but I'm going to send it as a byte, the value is 6. Yes. So in hexadecimal, this nibble, these first right here, will be 6. Do we agree? Now let's do again the same little exercise, and this time we're just gonna go and put on this 4, and it's 15. So what's the character for 15 in hexadecimal?
F.
So if I was writing this, if I was writing 111 in hexadecimal, do you agree that it would be 6F?
Yes.
Yeah.
Okay. Let's try another number. If somebody can, so we can try to one more before, or if you guys understand it, just humor me. Somebody throw me a large number out there. Anywhere.
255.
255? No, 255 would be too easy.
243.
Because that's the last number, so that's FF. 243, you said?
200.
243. So 243. Sorry. This, right? That's 243. So let's try now. The first nibble is 1, 1, 1, 1. So we would go over here. 1, 1, 1, 1. That's 15. We agree that's F, right?
Yep.
And then 0, 0, 0, 1, 1. And that's 3. So that would be F3. 243 is the same as F3. Do we agree?
Yes.
Yes.
Okay. Any other numbers you guys want to test or play with?
145.
145? All right. We'll start with 145. We know we got to turn this guy on. Right now. No. That's 192. 45, you said?
Yeah.
All right. So for the first nibble, we're gonna take and get 1, 0, 0, 1. That equals 9. And for the second nibble, we're gonna get 0, 0, 0, 1. So to write in hexadecimal 145, I would put 9, 1.
Now, why are you using only the right section of the second two boxes?
Because it's a nibble. Hexadecimal only sends each character is a nibble. It only has.
But the left side is also another nibble, right? 4
Yes,
characters.
the two together will create a larger number. So the hexadecimal value of 9, 1 is really 1, 0, 0, 1, 0, 0, 0, 1. The hexadecimal value or equivalent value in decimal is 145. So your hexadecimal value would be 9, 1, because each is a nibble. Your decimal value is 145. To write 9, 1 in binary, you would write 1, 0, 0, 1, 0, 0, 0, 1. This is not, when you're looking at this, you cannot think or try to pretend that it's not this is not base 10. This is hexadecimal. So a valid character is anywhere from 0 through F, which confuses everybody when they see a hexadecimal value that's 9, 1. 9, 1 is equal to 145, as you can see. Each nibble could only, to be able to calculate it, you have to use only these 4. You group them together and they give you the bigger value. Does that make sense?
Yes, sir.
Yeah.
All right. That was fun.
It really was fun. The chat box, they're asking if we're going to get this spreadsheet, and I want to know too.
Nah, I charge for this spreadsheet. I think I have a way of.
Yeah, we
And you
can pay
drop in the
you.
chat.
We pay you next year.
Yeah.
You charge for
You,
it.
you can have it as a viewer, and then it allows you to make a copy of it. Mind you, this is more for networking and stuff, and so I created it for my ITSS class so that they can understand networking. You can play with it, but it does every octet of networking. I think they do it here later too, in Coursera, which we can then at that point when Coursera talks about it in networking, we can look at the other columns here and A class, B class, C class, and all the other stuff. I'm sorry. Any other questions or concerns on the binary activity or tests before I pass it back to Chad? I'm so sorry, Chad. I just stole that from you.
I mean, hey, that's fine. Yeah, you booted in a networking lesson. That was nice. That was awesome.
It was. Thank you so much.
I mean, based on that, anyone have any other questions? Because I have nothing to say after that, honestly.
Can we go over everything to study for my A+ again? No, I'm just kidding. For everything that we did in the beginning, I feel like I forgot.
Yeah, that's repetition, my friends. Remember, the more we use it, the easier it is. Unfortunately, just like what some of us did, I learned Italian when I was in high school, and unfortunately, all I can tell you is io sono un poco ritardati. I can talk to you in Spanish, I can talk to you in Portuguese, but I can't tell you half of the stuff in Italian because the 2 years are useless. I never used it again. So we need to, unfortunately, even though we're not studying for the A+, maybe watch the videos again and go through it. And obviously when we're actually in the workforce, the more we use it, the easier it gets. And Google or manuals are always our friend. As long as we're able to decipher the material that's being given to us and learn how to ask questions, that's all we ask, is to be able to communicate, work as a team to learn, because not everybody in IT knows everything. And that's what's great about IT. No one has a niche. Everyone has something to give to someone else.
Definitely. I don't know. Greg, do you want to